Hi, my name is Sharon McCoy. I am one of the authors on the Biodegradable Materials module, and I've been teaching at Conant High School in Hoffman Estates for 12 years now. I teach biology and chemistry. I'd like to take a few minutes to give you an overview of some of the activities that you're going to find in this module. And starting with the first activity, the students have an opportunity to take a look at biodegradable and non-biodegradable packing materials. And they get a chance to test the effectiveness of the materials. They observe the materials, they immerse them in water, and in order to test their effectiveness, they pack the material around a raw egg in a Ziploc bag. They then take the Ziploc bags and they drop them from different heights to see if the two different materials protect the egg in the same way. After that test, they're able to enter into a discussion about what biodegradable materials are made of, and in what situations you may want to use a biodegradable material rather than a non-biodegradable material. In the second activity, the students go on a biodegradable materials hunt. They look underneath their sinks, they look in grocery stores, they look in various places to try to find what type of materials already exist as biodegradable materials and what types of things maybe should be those types of materials. In the third activity, it actually gets into the heart of the biodegradables module. The students get an opportunity to use a gelatin capsule, which is a biodegradable material, and these capsules are commonly used in the vitamin and the medical industry. The first thing the students need to do is make a 5% film, a 10% film, and a 20% gelatin. And they do that by taking a half of a gram of the gelatin capsules to make the 5% film. They add 10 milliliters of hydrochloric acid into a vial, and then they shake the vial to get the capsules to dissolve. Once the capsules are dissolved, they pour them into a Petri plate. They let the Petri plate dry overnight, and the next day, the film that is dried, that is formed, the 5% film they make a 10% film, and the 20% gel, because there's so much gelatin in the solution, actually stays as a gel, and we keep that in the vial. They can then use these materials to test the mechanical properties of the various substances. After testing the mechanical properties in the third activity, the students move on to the fourth activity, where they're going to test the degradation rates of the various materials. They're going to test the degradation rate of the 5% film, the 10% film, the 20% gel, the biodegradable packing material, as well as the original gelatin capsules. And they're going to test to see how long these materials take to degrade in different pHs as well as different temperatures. They're going to test in a pH 4 solution, an acidic solution, a neutral solution of pH 7, as well as a basic solution of pH 10. They're also going to test in various temperatures. A 100 degrees Celsius water bath, a room temperature water bath, as well as a 0 degrees Celsius ice water bath. They'll take different size pieces of these materials, put them in the solutions, and determine how long these take to degrade. After they've collected all their data, they graph the information. And by comparing with the rest of their classmates, they can determine which one of the materials degraded in the fastest amount of time and under what conditions. It also gives a great opportunity for the students to work together in teams, because these activities take a fair amount of time to complete. When they work together, they're able to finish those in a reasonable amount of time. In the last portion of the module, the students have an opportunity to do a design project. And their design project is to create a medicine delivery device. And they're allowed to use any of the materials that they've encountered within this module, as well as, besides the 5 and the 10% film, they can make any other types of films that they wish. And on a personal note, I had a student in class, actually was a special ed student, and he was struggling, and he really got into this design project. He came in before school, he came in after school, he came in on his lunch hour to make more films, more gels, put things together so that he would have this phenomenal project when he was finished. And when he was finished, his device completely blew away the rest of the competition in the class. He had a phenomenal device that lasted 10 times longer than anyone else in the class. So this module gives a great overview of biodegradable materials, how they're used, what they're made of, and it has a lot of interesting as well as thought-provoking activities.